All right, we are doing Trig Unit 3, Day 2, Part 1. So we're doing it out of order. This is actually Day 3 for you. It's broken into two pieces. The first Part 1 is straightforward use of the law of sines. The second one is a little bit of it's a little tricky. It tends to be the most confusing part, I think, of this whole unit. So I'm going to leave that for Monday. All right, so but other than that, today is very much like yesterday. You're going to get a formula and you're going to plug the right things in the right places and get an answer. So we're going to use law of sines to find missing measures. Okay, the law of sines in past I've gone through, I show you how it's derived and I kind of get funny looks. So I'm going to skip that part, but it relates angles to their side lengths. And this is what it looks like. So the length of side A, which is across from angle A, over the sine of that angle is equal to the length of side B over the sine of that angle is equal to the length of side C over the sine of that angle. Or you can use it in the reciprocal form. So you can have the sines on top and the side lengths on the bottom. Either way, whichever way works better or makes more sense, or either of these forms is going to work. So let's look at how we use it. And again, I'm going to tell you the information that you're given in the triangle because that might help you in the test in this unit. I don't tell you what formula to use. You kind of have to figure out which formula is going to work in this situation. So I give you these little mnemonics that might help you figure out more quickly whether you want to use law of sines or law of cosines. So here's a triangle ABC. And we're given angle, side, angle, and we want to find the length of A. So we're not finding all the missing measures, we just want to find A. Where is A? A is here, across from angle A. So we're just going to set up a proportion. Well, we need one side length and one angle across from it. We don't have that, but we can easily find angle C because we already have two angles in the triangle. Use triangle sum theorem. Subtract those two angles and we find this is 57 degrees. Now we are set to use the law of sines. So the side length A over the sine of its angle is equal to the side length C over the sine of its angle. So A we don't know, but we do know sine of 65. We do know what that angle is. And then C is going to be, side length C is 73 over the sine of its angle. Don't forget to put the sine. This is the other thing that people forget. Then we're going to cross multiply. So when we cross multiply, I'm going to get A times the sine of 57 degrees is equal to 73 times the sine of 65 degrees. And then to solve for A, I just divide out my sine of 57. And we plug that into our calculator. Actually, I would just plug the whole thing in and get the answer, not get the answer for the top and the bottom. The more rounding you do, the less precision you have, but it should be approximately 78.9 in length. So it's really just setting up a proportion, which is two ratios set equal to each other, allowing you to cross multiply and solve for your unknown. All right, next example. Oh, I guess you're going to do this one. You should find side C. And it is another example of angle, side, angle. All right, here's angle, angle, side. So I have angle, angle, side. And it said find the length of B. So B is here. And it makes it easy because I have angle A and side A and angle B. So I don't need to do anything additionally. I can just jump right into the law of sines. So A over the sine of angle A is going to be equal to B over the sine of angle B. I cross multiply 20 times, oops, let me fix this. Well, I fixed it, didn't I? So I have 20 over sine 70 equals B over sine 50. I cross multiply and I'm going to have 20 times the sine of 50 equals b times the sine of 70. And to solve for b, we divide out our sine here. And that's going to give us, again, I would just put this in my calculator for a more precise answer, about 16.3. All right, next example. Find the missing angles. So we're not looking for a side length, I'm looking for the missing angles. I have one angle, and I need to find the other two. Again, we can use the law of sines, but since we're looking for an angle, remember, we're going to use the inverse function, which means we're going to use an inverse sine. So whenever you're looking for an angle, if you can kind of get that stuck in your mind, it's going to be inverse function. But we are going to use the law of sines. So we have, I don't even have these labeled, I guess I should, B, C. So we have angle A and side A, and that's what we're going to start with. So 9 over, let's see, sine of 42 is going to be equal to side, this looks like an A, it's a 9, 13 over the sine of B. Just like before, cross multiply, 9 times the sine of B is equal to 13 times the sine of 42. Divide out the 9 because we're going to isolate the trig function. And we're going to end up getting the sine of B is equal to 0.9665. So since we're looking for the angle, we're going to use inverse sine of this ratio has to equal my angle B. Plug it into your calculator, and you find angle B is 75 degrees. And from there, you would use triangle sum theorem to find angle C. All right, so the last thing I have is a problem for you to try. And bring any questions to class.